up, guys? What's up? Going into CCENT ICND 100-105 Prep and Learning. Lecture in Lesson 5 Learning Binary. Guys, what's up, guys? What's up? This is going to be a big section, and this is going to be a little bit of something you guys are going to have to get used to a lot of. This is really the foundation, along with the lesson before, lesson 4, um, the foundation of leading up to it. Now, how much will you really have to know as far as binary conversion for the ICND? Not really a lot. You're not going to have many questions as far as that, but to know this goes beyond, guys, um, just knowing binary. You're going to use it for subnetting and etc. So binary as the basic design will basically spread to more areas. So this is something that you really got to focus on, and you do need to get it down. It's going to help in everything beyond from here. You've got to understand how binary works, and that's just all there really is to it. So I'm gonna pull up some stuff right quick here. We're gonna see if we can get up. I'm gonna see if I can get up a binary table. And get a general idea how binary works. So I'm looking for a decent table here. Okay, so this is a pretty good layout of how binary should look, and I like this, so let me grab this, and then we will switch over. From there. Okay. Alright, so binary is mostly seen in movies, basically like The Matrix. Not true binary, but it's ones and zeros. Ones and zeros, guys. Binary is nothing but ones and zeros, and that's just how binary works. So basically what you need to know for binary is that 1 is on and 0 is off. This is how binary communicates. Electric pulse, no pulse. Or a light, in the case of fiber, a light, no light. So that is the purpose of the ones and zeros, and this is what physically travels across the cable. Copper, fiber, which is light, and so on from there. So binary is first, basically concept is where we're all familiar with decimals. Let's say like 128, 60, 64, 32, etc. 16, 8, 4, 2, 1. So we're all familiar with regular numbers and how math, basically the basics of math. If you're not, you're probably going to be screwed at this point, but I'm confident that everybody is going to be familiar with this. So I'm going to put these dividers in there. We're going to break this up because basically, even though I listed numbers, there's a purpose behind this. This is basically part of how binary works also. So we know it's ones and zeros, so what you're asking is, how does binary have anything to do with 1, 2, 4, 8, 16, 32, 64, up to 128. So binary comes in 8. If we look here, this is going to be 1, 2, 3, 4, 5, 6, 7, 8 different digits. So they refer to it as an octet. So the first thing you're going to learn binary is converting it from basically decimal and IP address, because basically that's where your basics of binary is going to stand in the networking part. But this is the first thing to learn in binary. You need to memorize that, and this is how I usually, when I first memorize it, was 1, double of 1 is 2, double of 2 is 4, double of 4 is 8, double of 8 is 16, double of 16 is 32, double of 32 is 64, double of 64 is 128, and you stop there once you get up 8. Just remember you start with 1 and you just keep doubling it. Double the number. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 goes to 8, 8 plus 8 is 16, 16 plus 16 is 32, so basically doubling. Now here's the wild thing. You look at this and you can count from all the way from 1 all the way to 255 off of this setup in binary. So we're going to, let's go below here, and here's where it's going to get tough. So you're basically going to have something to this extent, guys, is what binary, and it's probably going to be closer together. I'm just trying to line it up for you guys. That way it's a little bit easier to see visually. Up. Trying to just line it up as good as I can here. So down here at the bottom, this is binary. And what this would equal, if it was all together, this is how you're going to normally see it, is like this. It's the same thing. Have 8 numbers. This is just spaced out so you can visually see how it matches up to here. This is what it does. Now what does this actually equal as far as numbers? So this right here does have an actual decimal number to it. So this is binary and this is considered decimal. So how do we determine what's this? Zeros you don't count, 1 you count. So follow this slightly. So we're going 128 plus, okay, we don't got a 1 in the 64, so we're going to skip it. We've got a 1 in the 32, so plus 32. We don't have a 1 in the 16. We don't have a 1 in the 8. We don't have a 1 in the 4. We do have a 1 or an on bit in the 2, and we do have 1 in the 1. So hopefully that makes sense. Think of the 1 as on, or in this case, if you're translating to carry, whatever the number is, this should be your main setup right here. This will always carry over for binary. So you'll always use this. So if you have to, when you go into your certification, the first thing you need to do is, probably before you even get really going, is go ahead and write this down if you're scared you're not going to memorize it. Write it down. I will write this down. Well, I memorize it, but to be honest, when it comes to time to look at something, I'll write it down because I've made mistakes because I jump ahead and not think about it as a binary state. So that's what we get. So what does this binary really mean? So we got 128, and for the sake of showing you guys what it actually equals, I'm going to type it in over here. 128 plus 32 plus 2 plus 1 equals, so this binary code equals 163. So 163 is what this binary code equals. Put the phone out of the way. So in the end, this or this, whichever way, you're going to mostly see it like this, equals this. This is basically showing the work of it, because here's what the table is. So you should always look at binary as a table. You're going to have something, and then, well, we'll jump to that in a minute, but this equals to this. So you're going to have something like this. So you might have a question like this. Did I even spell decimal right? I think so. And basically you would look at this table, and first you would say, alright, that's a 128. 128 plus, there's not one in the 64. There's not one in the 32. We do got one in the 16, so 16. we've got one into 8 placement. That's 8. Then we got one in the 4 placement, so that's 4. Got one in the 2 placement, so plus 2. And we got one in the 1 placement, that's plus 1. So from here, you're just going to do basic math. Once you converted this and it comes into something like this, you're going to do basic math. Now, eventually, you do this enough, you will pretty much be able to know it right off the bat over time once you do enough conversions. But for the sake of making sure that everything's right, we're going to punch in and do this conversion. That way we know the actual answer to that question. 8 plus 4 plus 2 plus 1 equals 159. So the answer would be answer 159 in decimal. I did misspell decimal. So it would be 159 in decimal. So alright, so we look at this and we're going to go ahead and we're going to leave this table up here. That way you guys kind of know. So how this is going to apply is you got what they call IP addresses, as we talked about earlier. And binary is really what everything's, basically all the communication through a network ends up in binary. So an IP address would be something like this. That's in the decimal format. Now, what would the binary format of something that looks like? Well, 192, can we, and here's a quick way, this is another route you can basically go. From 192, can I take 128 out of it? I can. So I got 192 here, and we'll just do it in the calculator for the sake of being right. Instead of, that way, make sure I don't actually make a mistake. But I will tell you, you will not have a calculator in the ICND2, so be prepared to use your dry erase board or paper, or whatever they give you. So we're going to start with 192. We're going to minus out 128. So we got 64. So luckily this is going to be easy. So we can take 64 out of there, and then we're left pretty much with 0. So the binary format would be that, and then dot. Put a dot there to represent the first part of the IP address. So that's 192. So as you can tell, that is the first octet. Is decimal easier? Yeah, it's easier. It's a lot shorter. All it is a shortened version of the binary here. But you need to know binary because when you subnet, you just can't look at this in subnet that easily. It makes you really truly understand subnetting through binary. So how about 168? Won't have it quite as easy. We can't take 128 out of it, obviously. So we want to put in 168 minus 128, and we're going to be left with 40. Can we take 64 out of 40? No. Can we take 32 out of 40? We can. And that's going to leave us with 8. So can we take 16 out of 8? No, we can't. Can we take 8 out of 8? Yes, we can. So that leaves us with 0. So the next 3 we know will be zeros. So we got 4 and 4. We got a total of 8 bits. So we're halfway done here. Now this conversion to 192 and 168 is this conversion. So the next one's going to be really simple. This is a 1. So obviously we're going to have 7 zeros and then a 1. Let me make sure I typed in that enough. 1, 2, 3, 4. I did. 1, 2, 3, 4. So that's 1 in binary. We're almost done. The last part. So 10. Can we take 128 out of 10? No, we can't. Can we take 64 out of 10? No, we can't. Can we take 32 out of 10? No, we can't. Can we take 16 out of 10? No, we can't. Can we take 8 out of 10? Yes, we can. That'll be a 1. So that leaves us with 2 left. Can we take 4 out of 2? No. Can we take 2 out of 2? Yes. And then we're left with 0. Can you take 1 out of 0? No. So now we have successfully turned an IP address into a binary format. Just gonna see. Let's see if we can. Let's see if we can get. I'm gonna widen these fonts for you guys. Let's go up to a. Let's go to a 20. There we go. So 192 is represented by one in the 8th slot, one in the 7th slot, and then the rest is zeros. And once again, for 192, can you take 128 out of 192? Yes, you can. Leaves you with 64. Can you take 64 out of 64? Yes, you can. Can you take a 32 out of 0? No. Your goal is basically 0. There's no negatives related in binary. So no negatives. So that's 192. 168, same concept. Can you take 128 out of 168? Yes, you can. That leaves you with 40. You can't take 64 out of 40. You can, however, take 32 out of 40. That's going to leave you with 8. Can you take 16 out of 8? Nope. So that's a 0. Can you take 8 out of 8? Yes. So that's a 1. Can you take 4 out of 0? You can't. Can you take 2 out of 0? You can't. Can you take 1 out of 0? You can't. So that's what gives us the 3 zeros. That's binary conversion. This is the table you need to go by. You need to memorize this. And this is 8. There's going to be 8 slots. So the simplest way to remember it, in my opinion, is start with 1 and just double. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32. 32 plus 32 is 64. 64 plus 64 is 128. Hopefully that makes sense. So if all these are 1, see, I need to count how many I'm putting in. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It would be equivalent to 255, 255, 255, 255. That's the highest address you can have, which is all ones. And if you have all zeros, of course you're going to have an IP address of all zeros. This is considered a broadcast address. So you'll never, an IP address will never be this, because it's considered a broadcast address, and an IP address can't really be zeros either. Remember that the 1 bit is considered an on, so it's an on, off, off. Kind of reminds me of Morse code, off, 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 off. It's similar to Morse code somewhat. But for what they on and off represents, it is this up here. This is your table. You memorize this, the rest is going to fall into place when you're converting from an IP address to a binary, and vice versa. If you're converting a binary back to an IP, as we can see here, or a decimal format, as they would say. So I'm going to clear this, and I'm going to let you guys, I'm going to give a random question here, and I'm going to give you guys some time to figure it out, and I'm going to leave this table up here for you guys. So what I'm going to do is I'm going to give you an address. Here's your IP address. But you know what? Better yet, let's start off with something simpler. I'm just going to do one number at a time. So here's your number that I want you to convert into binary. I'm going to convert 200. So take a minute, write it out in binary on your piece of paper or a notepad, whichever you prefer. I'm going to give you guys about a minute to do that. and to figure it out, and then we will go over it together to make sure that you are correct with your answer. Now I'll expect you to be able to convert quicker in most cases, but this time I'm going to give it a little bit of extra time just because should be something new to you unless you are familiar with binary. Okay guys, if you need more time, pause the video. I'm fixing to go over the answer. So for 200 in binary, can we take 128 out of 200? Yes, we can. So the first digit, or the first binary, would be 1. And that's going to leave us with 82 left. Can we take 64 out of 82? Yes, we can. That's going to leave us with 82 minus 64. It's going to leave us with 18. Can I take 32 out of 18? No, I can't. Can I take 16 out of 18? Yes, I can, and that would leave me with 2. Can I take 8 out of 2? No, I cannot. Can I take 4 out of 2? No, I cannot. Can I take 2 out of 2? Yes, I can. So now I'm at 0. The rest have got to be 0. So our conversion would look like this. 1, 1, 0, 1, 0, 0, 1, 0. This is the binary for 200. If you've gotten that correct, you've pretty much already understanding binary. The concept applies all the way across. It really, I mean, you can have more difficult, or when I say difficult, it's not truly difficult, but it means more time to figure out, for example, maybe an IP address. So let's do one more. I'm just going to throw a random number out there. Remember, I can't be above 255, obviously. So I'm just going to close my eyes. I'm going to hit 1. I'm just going to hit 3 digits on the keyboard. I don't even know what it is. Now look, 196. So we're going to be converting 196. So I'm going to give you guys some time. I'm going to be a little bit quicker on this. So I'm going to give you about 20 seconds. Alright, so let's go ahead and start working this out. So I'm going to show my work a little bit. So I'm going to put the binary above the 196. That way you guys can see the process in case you got the first one incorrect. So can I take 128 from 196? I can. So my first digit, or my first binary bit, will be 1. Let's just go ahead. So 196 minus 128 gives us, and I'm going to try to keep this as clean as I can, a 6, a 6, and then an 8, so we got 68 left. Can I take 64 from out of 68 here? I can. Remember, the 64 is up here. We're looking at the binary, so we're trying to make our binary code and ones and zeros based on this format equal to 196. So 128 plus 164 is going to give us 180. Hold on. Shoot, I should know this off the top of my head, but I got. So 128 plus 64 is going to total us at a 192. I guess because I'm looking at this down here. So from the 64, we're going to be minusing out. I meant from the 68, we'll be minusing out 64. That's going to leave us with basically 4. So we're able to take 128 out of 196, and then we were able to take 64 out of 68. Can we take 32 out of 4 that is left? No, we cannot. Can we take 16 out of the 4 that is left? We cannot. Can we take 8 out of the 4 that we have left? No, we cannot. Remember, if we can't, it is a 0. If we can, it is a 1. Binary is only 1 and 0. Decimals is pure digits. So when you hear binary, you need to remember 1 and 0s. If it's decimal, it's basically like a normal math number. So you should learn about decimals basically in school. So can we take 4 out of 4? This digit would be 1 because yes, we can take 4 out of 4. And what is that going to leave us with? Now we're going to be at 0. So we've completed the number and we're down to 0. So the next 2 digits automatically will be 0. And if we wish to work it out, it would be, can we take 2 out of 0? We can't. Can we take 1 out of 0? We cannot. So this 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. Is binary for 196. So 1, 1, 0, 0, 0, 1, 0, 0 is the same as saying 196. This is going to seem stupid right now, and you're going to say, why do I need to learn this? And is there calculators out there for it? Well, of course there is, because we can actually check ourselves simply right here on this calculator. I change it to binary 1, 1, 0, 0, 0, 1, 0, 0. And to do that, you would change your calculator to programmer out of view. But you will not, and I repeat, you will not be able to use that during the exam. So you need to learn how to do this by hand. Memorize this up here. You need to memorize it. This bit is equals 1. If it's a 0, you do not count it. This bit equals 2. If it's a 0, it does not count. This bit equals 4. If it's a 1, it counts. So it would be the opposite. We would be plussing 4. If we were to work it out, we're going to work it out kind of backwards, which is fine. This bit is 8. Do we got a 1? No, so we don't carry it. This bit is 16. Do we got a 1? No, it's a 0, so we don't carry it. This bit is 32. Do we got a 1? No, so we don't carry it. This bit is 64. Do we have a 1? Yes, so we carry it. This bit is for 128. Do we got a 1? Yes, so we carry it. And if you add these up, they will be 196. As you can see here, 128 plus 64 plus 4 would give you 196 because we took all of those out to equal 0. Guys, this is binary, and you really need to understand it. You need to work problems out till you feel comfortable with binary. Binary it's a lot of times people make it harder than it should be. You really don't have to understand this as far as the exam goes. This explains how the cable actually works, but you will need to memorize this by heart. You need to memorize this right here. You will be converting IP addresses. You will be doing something around subnetting. If you do not learn binary, guys, you will not be able to subnet easily. You're going to find it very difficult, and it's going to be tough. The better you learn binary, you understand it, the easier subnetting will be, I promise you, from there. And it will make a lot more sense because it's going to be based off of this format on how you subnet on your IP addresses. So the best thing I can tell you is be able to convert IP addresses. If you want to go to your computer and look at your IP address, in this example, let's just go with the command line IP config, and we got here my IP address 192.168.22.1. To convert that into binary, you want to be able to convert it to binary easily, as that is even my VM. I've got a 192.168.207.1. As you can see, I have a lot of this is VMware from here, and so on from there. So 192.168.10.4. So you will see that you need to be able to convert these IP addresses. So look at your IP address on your machine, be able to convert it, be able to convert other random IP addresses, numbers, and digits. If you can do as simple as one number, start off doing one number, like 96, 200, anything between 1 and 255, or even 0 through 255. You need to be able to convert it. So why is 255 the max number? Once again, that is when you have all ones equals 255 in this format. So you cannot go above 255 in an IP address. So guys, I hope that this video has been very useful for learning binary. Guys, you will really, if there's one video that you really need to focus on, it's this one, along with the OSI model. It lays down the foundation for the upcoming videos. OSI for troubleshooting. This right here, you're going to need it for subnetting. You're going to need it to understand how wildcard masks work, and understand how broadcast addresses work, network addresses work. If you learn it from the binary standpoint, it makes all of it a little bit easier. If you ever get confused, you can always translate binary and know exactly where it is or what the answer is. So understand binary. There is a few methods. Like I said, I'm showing you methods that is simple, but if you know math really well, long as you know this basis and setup, you can do it by memory, or you might find a quick way to figure things out. As you will see that the subnetwork and so on from there, these quicker methods may help. So if you get it down and you learn the quick methods and you're comfortable with them, they might save you time on the ICND1 exam, which helps because you want to spend most of your time in the troubleshooting sections or areas that maybe you're weaker at, that you will be at the router trying to troubleshoot simulator wise. So guys, that does it for this video, this lecture, the lecture 5 for learning binary. If you have any questions, feel free to PM me. If you found this video to be useful, please follow and subscribe. If you want more videos, you can find them in my playlist under the CCENT ICND1 playlist. Until next time, guys, I'll see you in the next video. Peace.